All right, guys, we're going to take a look at the next part, which is the multiplication and division rules. Now, for you guys, multiplication and division will be far more common. You do need to know how to do everything, but that's the most common. And so when we do these things, we find sig figs after every calculation. And so you can have multiple layers of it, but multiplication division is the most common. So I'm going to show you how to do this with some examples. So we're just going to come up with some quick examples to kind of help us out. And then we're going to go from there. So I'm going to go ahead and come up with a quick example. And so let's say that you're in the lab and you are finding density. So hopefully you would remember the formula for density, and the formula for density is mass divided by volume. So there's density, and that's going to be mass divided by volume. So M over V. And so actually it should be a lowercase m, but we'll fix that real quick. There we go. Don't write a lot of lowercase letters, but that is technically correct. So let's say you went onto a balance in the classroom and you got a mass of 12.65 grams. So that was the mass that you got. All right. And so then you found the volume, and our graduated cylinders are not always quite as accurate. So let's say that you found the volume to be 6.2 milliliters. Okay, so now we would do the math. The math is 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 what we would do, and then we would have to round that answer. So I'm going to go ahead and do that math real quick, and you could do that too. You could just have your calculator out, run that through, and we're going to do the math, and I'm going to get a big old number, and I'm going to write that out, and we're going to determine how much of that number we're going to get to keep. And so I got 2.04032258 1. I mean, that is a number, right? Well, we don't want all of that. Like, we need to figure out how much of that we're going to keep, and we're not going to keep all of that because it's way too many sig figs. What this is saying is we get the super, super, super accurate measurement when we know that we did not get a super accurate measurement because our graduated cylinder really is not that accurate. It's a fairly inaccurate device. It only measures to the nearest tenth. So we can't have an answer that's this accurate. So we need to round that. So what you're going to do is you're going to come over here and you're going to count your sig figs, and you're going to say, okay, we've got in this top number, the 12.65. I would come in from the left because I do have a decimal there. And 1, 2, 3, 4. So that would be, the top number would be 4 significant figures. But now look at the bottom number. The bottom number also has a decimal, so I'm going to count from the left, but it only has 2 significant figures. So what that is telling me is that when I report an answer, I only get to report 2 significant figures. So we're going to go over here and we're going to look at our choice, and we got all these numbers. Well, you're going to want to keep the ones that are farthest to the left, and so you get to keep 2 of them. So what you do is you go draw a line where you got 2 numbers. I get to keep the 2 and the 0. So now we look at the 4. The 4 tells us, okay, we're not going to round up. We're just going to leave it alone, and then I'm going to end up getting rid of all of that, and that would report a final answer of 2.0 grams divided by milliliter. So that's correct with sig figs. It has 2 sig figs, just like the least accurate value. So you just match your sig figs to the one with the least. So that's how you do multiplication division. You just go through you count your sig figs, and you make sure that your final answer has that many sig figs. And so that's pretty straightforward. Now, when you're adding and subtracting, it's a little bit different. So multiplication and division, same rules. Count the smallest number of sig figs and round your answer to that value. Now, if we were adding, we can kind of take the same situation. We can go 12.65, and we could go 6.2, and let's add those two numbers instead of multiplying them. Okay, so here's the difference. When you are adding and subtracting, you are looking at the number of decimal places, right? So what we're going to look at is the decimal places. So if we look here, the 12.65 contains 2 decimal places, where the 6.2 contains 1 decimal place. So what that's telling us is that one number is more accurate than the other. And so we've got the tenths and the 100ths. So this is actually accurate to 1/100th, where this is only accurate to 1/10th. And so what we do is your answer gets the same number of decimal places as the one with the least. All right. So it's the same idea. It's just we're going to have a different outcome because there's a slightly different rule. So we're going to go ahead and add this up. And so we're going to get 18.85. And so that's the number that the math does. Now the math is not different. It's not like the math is different. It's just the rounding at the end is different. And so we probably should have given those guys a unit. So say they were grams, right? So this is grams. So now we're going to have a final answer. So what we do, same trick. We get to go over here and we get to say, okay, you get to keep 1 decimal place. That's not numbers, that's decimal places. So I get to keep a single decimal place because that one has 1 and this one has 2. So I get to have 1 decimal place. So I get to keep 18.8. This is what I get to keep, 18.8. But since we're rounding here, we're going to go ahead and round this correctly. And so the 5 actually tells the 8 to round up. So I would report an answer of 18.9. I don't like not a big fan of the highlighter there. So let's take that out. There we go. So let's go 18.9 grams. So look at the difference here. If I would have used the rules for multiplication division, I would have had an answer of 19 because 2 sig figs versus 4. But since I used since I used the addition subtraction rules, I am concerned not about I'm not concerned about the same things. I'm concerned about decimal places. So now this value is going to be accurate to the nearest tenth. See, it's 18.9. So that's accurate to the nearest tenth. And that is what we wanted. Okay, so we got 2 separate sets of rules, and we got to keep them straight. Right? So count your lowest sig figs, round to that value for multiplication division. Look at your decimal places, round your answer to the least amount of decimal places for addition and subtraction. All right, so let's go back over to the notes. You're going to see that there are some examples there. So we're going to work through those, and I'm going to give you guys some practice problems to work on your own. So let's go ahead and slide back here, and we're going to take a look at those. So let's go ahead and zoom in. All right. Okay. Oh, don't want to do that. Okay, so the key thing here is you actually have to do sig figs twice on some of these. And so like on this first one, we're going to do sig figs over here in the multiplication part, and then we're going to do sig figs a second time for the division part. So the first thing we're going to do is, and you can do this on your own calculator. It's a good idea to be following along, not just listening. So I'm going to multiply those two numbers, 3.016 times 4.23, and I'm going to get a number, and I'm going to go ahead and write that down for you guys. And I got the number I got for this is 12.75768. Okay, so what does sig figs tell us? Well, we multiplied two numbers. The number over here on the left, how many sig figs does that have? Well, that one has 4. This one has 4. And this one over here, that one right there, that one only has 3. So our answer is going to get 3. So what I would do is I'd take 12.75768 and I'd round it to 3 sig figs. Well, if we're rounding to 3 sig figs, it's going to be 12.8. So now my second problem I'd have to do would be 0.0031 divided by the 12.8, because the 5 rounded me up. Now I'd have to do a math problem again and get sig figs a second time. Okay, we can count our sig figs real quick before we do this. This one right here, coming from the left, it would have 3 sig figs. Coming from the left, they both have decimals. Oh, look, they both have 3 sig figs. So our answer has to have 3 sig figs. Okay, so 0.0031 divided by 12.8 equals, and then we get to round that to 3 sig figs. And so I got 0.000242188. Obviously way too many, and we only get to keep 3. So I'm coming from the left side, and I don't care about those zeros. The 2, the 4, the 2, I get to keep those. So then my answer to that number 1, although I'm kind of scribbling all over the page, I'll get that final answer. That final answer for number 1, I'll go ahead and maybe I'll slide up here. Oops. Maybe we'll slide it up a little bit. So that final answer for that number 1 is going to be 0.0000242, and then that would be meters per second. So that's that number 1 down there. All right, guys, I'm going to pause the video. I'm going to run out of time on this one, but I'm going to pause that, and then I will finish up